Welcome back, everybody. We are going to do some reviewing for section 3.5. So this is actually 3.5 part A on solving systems of equations by substitution. Substitution basically means we're replacing one thing in for another, like a substitute teacher. This method is a more algebraic way to solve systems of equations. When we're solving by substitution, we need to make sure that we take one of the equations and solve it so that either x or y is alone. See if this is already done in one of the two equations if you're given. If not, you need to pick an equation and make sure that you do this. Substitute that equation into the other one for the variable that you have alone, and then simplify and solve for the remaining variable. This should result in x equals or y equals some value. Once we have that, we place that value back into one of the two original equations, doesn't matter which one, and solve for whichever letter is left. Both answers are going to be written as an ordered pair. That looks like this in parentheses. This is our solution. There are two special types of solutions. So if you get some kind of a true statement, then you have infinitely many solutions. If you get a false or untrue statement, then these lines are parallel, they will never cross, and have no solution. Let's try a couple. I'm going to start with A. So we have x plus y is equal to 9, and 2y minus 7x is equal to 26. First thing I'm going to look and see, are either of these already solved for either x or y? And they're not. So I'm going to pick the top equation, and I'm going to get x alone. So to get x alone, I'm going to subtract y from both sides. So my new equation is x is equal to 9 minus y. Because that's equal to x, I can take that whole thing and plug it in right there and only there for our new equation. So I keep 2y minus 7, and the only thing that's changing is that letter x. So we have 9 minus y in here. Now, all I have are y's, and we can solve for y using this purple part. I'm going to start with distributing that negative 7 to get rid of the parentheses. That gives us 2y minus 63 plus 7y is equal to 26. These are like terms, so we have 9y minus 63 is equal to 26. Add 63 to both sides. 9y is 89. Divide by 9. And I really can't divide 89 by 9. I can't reduce 89 with 9. So for this system, our y value is 89 ninths. So we have two options. I can take this, y is equal to 89 ninths, and plug it in to any y I want. Or if you don't want to worry about the fraction, then we can solve the top equation for y and rework our problem. I think I'm going to go that route for our notes. And then in class tomorrow, we'll talk about plugging this in. All right, so now I'm going to solve to get y alone on the top. To do that, I'm subtracting x. So we have y is equal to 9 minus x, and that's going to go right here in the second equation for y. So we keep the 2, we don't write the y, minus 7x is equal to 26. This 9 minus x goes here in our parenthesis in place of, or substituting, for the y. Now I can distribute to get rid of the parentheses. We have 18 minus 2x minus 7x is equal to 26. These two are like terms, so 18 minus 9x is equal to 26. Subtract the 18 over. Negative 9x is equal to 8. Divide by negative 9. And we have x is negative 8/9. This is our answer, or our solution to that system. Letter B. I'm again going to look and say, do I have anything that is solved for either x or y? And I don't. So I'm going to take this top equation and I'm going to set this equal to y. I'll start that by subtracting 5 from both sides. So 3x minus 5 is equal to negative y. Remember, y is not alone. We have to divide by that negative 1 every single thing. So negative 3x plus 5 is equal to y. I'm going to put this equation right here for that y. Remember, everything else gets written the exact same except for the y itself. So 6x plus 2, we don't write the y, is equal to 10. This goes in here, negative 3x plus 5. Now we can solve. I'm going to start with distributing that 2 to get rid of our parentheses. So that's negative 6x plus 10. These are like terms. 6x minus 6x is 0. So I'm left with 10 is equal to 10. Well, 10 equals 10. That's a true statement. And if we look back towards the top of our notes, a true statement means infinitely many solutions. And that's what we write for our answer. Letter C. I'm going to, again, nothing solved, so I'm going to take this top equation, because I just have a single y there, and I'm going to rework that so that y is alone. I'm going to add y. And subtract 5. Now I can put that right there for that y. So 6x minus 5 is equal to 2y. And remember, this right here goes in here. So 3x minus 5. We're placing that in for the y. That's what y is equal to. I'm going to distribute my 2 We have 6x minus 5 is equal to 6x minus 10. I'm going to move my like terms together with the 6x's by subtracting. So 6x minus 6x is 0. So I'm left with negative 5 on the left and negative 10 on the right. Well, negative 5 does not equal negative 10. That is a false statement. And so this has no solution. They are parallel lines and will never, ever cross. That's all for tonight. Study up for your test. We'll see you tomorrow.